All right, team. Thanks for joining us for this session. Arjun, you've been leading the charge on the new sensor array integration. Lisa and I wanted to get an update, especially on how it ties into the broader system architecture for our clients' needs.
Exactly. We're looking at the bigger picture for the next project phase.
Okay, well, as you can see here, we have the SPI interface on the STM32 microcontroller. It's handling data packets from the CPU very well, using its accelerometer and gyroscope. We've implemented a DMA buffer, which is really helpful for reducing on the latency, especially in the ISR latency. The firmware is running a free RTOS firmware update, which is seeing about an 85% utilization. So it's well within our timing budget, and as you can see, the MIPS is definitely handling it much.
Hold on a moment. When you say things like SPI interface and DMA buffer, could you please elaborate for somebody who's not really too familiar with the jargon? We have potential stakeholders who need to understand the functionality and the benefits of the system, not necessarily the pesky implementation details.
Right. Well, SPI is a serial communication. It's how the chip will talk to the sensors. The DMA buffer is just a way to move it more efficiently. As you know, without it, the processor wouldn't be able to run nearly as fast. So we're not kind of wasting time using our KPIs or any other protocol like that.
Arjun, can you help us connect this to the why? Why is this specific sensor array crucial to our particular client's product line? What problems does it solve for them directly while trying to understand the value proposition for our client and the specific use case? Not just the fancy stuff, the technical elegance.
Well, I mean, I've shown you all the data. I mean, I can see if I have any more data, but really, like, these numbers, they just prove exactly why everyone should do this way. It just makes the most sense. If you want really accurate motion tracking, this is the way to go. It provides much better data fidelity compared to all the other alternatives that we've been considering in the last quarter. It's just fundamentally better engineering. I don't see why you wouldn't want to take it. Like, I don't know, if I can't convince you otherwise, I can send you a full 30-page report if you'd like. Is that what you
We
want?
appreciate the technical depth, Arjun. Perhaps we can pivot slightly. David, do you have anything else that you'd like to?
No, I think we have enough understanding for the challenge. Thanks, Arjun. Appreciate it.
Thank you.
Arjun, thanks for setting this up. We're really looking forward to seeing the revised proposal on the integration, especially how it addresses the challenges that we discussed before.
Yeah, so following our previous meeting, I really took aboard some feedback, and I really tried to make it less technical and more kind of able to be understood by a broader audience, kind of reducing the unnecessary kind of jargon. So I have these slides over here. So as you can see, we have this kind of modular structure. It's a lot more kind of simplified. We kind of have like our main data input from that side, our main instruction unit over there.
Arjun, I noticed you've got a lot of text there. I wanted to perhaps maybe ask you to use another mode of communication. A quick diagram or maybe just a sketch would make this a little bit more interactive. We're all visual learners here.
Oh yeah, sure, that's a really good idea actually. Rather than me kind of explaining everything and kind of giving the full paragraphs about every single function in this system, let me kind of draw it out and visualize it. So yeah, let's kind of think about it this way. Let's kind of think about our modular blocks as Lego blocks. So we have our Lego block, we kind of have little studs over here, and we have each one fits into another piece perfectly. They kind of fit and pass whatever they are, they kind of join together, and we get a bigger piece. So we can kind of think about that in the same way as our modular block. So let's imagine that we have our main data processing block as this kind of block that looks like this with two studs, and we have our data information block, which is like this with three studs, and then we can have our central processing block as this one, which has our output ports, which are 5. So you can imagine that, yeah, they kind of go together nicely and all feed into this block.
Roger, that's a much clearer way of seeing it. Thanks very much. The Lego analogy works really well.
Yeah. Thank you very much, Arjun. Can you also tell us what our understanding is of our current baseline knowledge regarding this architecture, just so you know where to direct our focus?
Yeah. Of course, yeah. So I kind of felt that maybe I was assuming some previous level of knowledge and I shouldn't really have some unconscious bias. So
Alright team, we need to decide between solution A, which Arjun you've championed, and solution B, Lisa, which you've championed. Arjun, would you like to talk about your solution first?
yeah, so I really think solution A is the way to go. I really think it aligns closely with our main goal of kind of future-proofing this entire system, kind of having a long-term, good, strong project. And I think that even though it had kind of a bit more of an upfront cost to it, I think that the overall performance indicators that we've listed out here really signify that it's going to help our product succeed well in the long term. So I really think it gives us a much better return on investment.
I understand your analysis, Arjun. However, it's an interesting point about the long-term ROI. However, I think we need to prioritize our clients' needs here. My concern with solution A is that the immediate impact on our timeline would disrupt the next client's deliverable. Solution B, perhaps less scalable and less elegant. It gets us to the market 3 months faster, which is a critical factor for this client.
Yeah, I understand. That's a very good point, actually, because with this particular client, speed is very important. We really need to get this product out there as soon as we can. And I realize that kind of my background might have influenced that choice of leaning towards solution A, kind of having that nice, perfect, polished product on the get-go. But yeah, I think in this specific case, yeah, do you see any other points in kind of solution A that you think maybe I should kind of did not consider that well, or maybe I should have another look at, maybe consider it from perspective?
The competitive landscape is a bloodbath right now. Every month counts. We need to get to market as soon as possible, and that should be our first priority.
I see. Yeah, this is a very key factor. Yeah, definitely. So David, from your perspective, from a more strategic perspective, how do we kind of weigh in against these two main factors? Kind of having a perfect product or having a product out there in the market as soon as possible. What is like the main thing that we're trying to achieve? Like, how can we assess our indicators with our key objectives?
Well, Arjun, that's definitely the right question. For this project, our client's main issues are speed to market. We can make follow-up adjustments further down the line. However, it's vital that we don't compromise on core functionality.
I see. So really considering all of your perspectives, really it's about the time to market, which is really important for this client. So really we need a minimum viable product to kind of get over the line, good enough that we can put on the market. So yeah, I think even though solution A might have technically been the kind of better option to go with, in this particular case with this particular client, we really should prioritize solution B because of its more effectiveness with our particular client.
It's a great assessment, Arjun.
Thank you.
Agreed. Thanks, Arjun. That kind of balanced thinking is precisely what we need, looking at the ultimate goal of this particular project. So thanks very much. It's exactly what we needed.